Okay, great. We're recording. So yeah, welcome to everyone. I'm just going to share my screen with you. To begin with, we're going to go through the presentation. Okay, great. Hopefully you can see the presentation on screen now. If there are any issues with seeing that, please do let me know, but I think you should be able to see what I can see there, which is great. So today's webinar is to present to you another new product that we've developed. This has been a product that's been in our development cycle for over a year, maybe 2 years now. It's a product called the Smart Factory. It's a product that we've wanted in our portfolio for quite a long time now. And it's designed to address the needs within manufacturing engineering, robotics, Industry 4.0, and many other key areas of training and teaching. As we go through this presentation, I'll explain a little more about that. You can see a visual of the product on the screen now, and when we run the demonstration, you'll find out more about the size of the product and this type of thing. You'll also find on there as well the web link for this product. I just thought I'd put it on here because that's what that's the web link that contains all of the information that your customers might ask about this particular product. It includes access to the curriculum. There's a video on there and all sorts of things like that. Okay, so speaking of a video, I'm just going to commence by showing you a short video of the Smart Factory, which hopefully will, for 2 or 3 minutes, be a video that you can send out to your customers and they'll be able to see exactly what the Smart Factory does and what it's designed to address in terms of learning outcomes. So if you just give me a moment, I'm just going to link to that.
So that the video play music. You can share screen with sound, can't you?
Can you? Right, okay. Didn't know that. Okay, I'm just getting the video up. Just bear with me a moment. Okay. Hopefully you can see this. The Matrix Smart Factory from our Automatics range of equipment allows students to gain experience of a number of processes and technologies that are commonly used in manufacturing. A key requirement of learning across many mechatronics, engineering and manufacturing qualifications is to enable students to understand the technologies that will continue to influence global Industry 4.0 growth. Our system is designed to be rugged, desktop and easy to use. This allows students to work in small groups and get hands-on with equipment as quickly as possible, therefore experiencing the challenges and decision-making involved in successfully setting up, building, programming and operating a smart factory. Our smart factory includes a gantry system, a conveyor system, and is controlled with the user's choice of educational MIAC PLCs or an industry standard Siemens S7 1200. The smart factory gantry makes use of a limit switch, stepper motor with 3 inputs, and a plunger. Students follow our worksheets to control the stepper motor and drive it using a PLC, and in turn control the plunger mechanism. The suction device then delivers parts onto a conveyor belt, which is fitted with inductive and capacitive sensors, allowing parts to be distinguished from each other and placed automatically into bins. 2 laser light gates are also fitted for triggering and timing of the conveyor. The Smart Factory is also compatible with the Matrix Allcode Robot Arm Production Cell, which is a standalone set of equipment designed to replicate the purpose of an industrial robot in a factory. The robot arm can be used to collect parts from the conveyor and add colour sensing to the overall system. The robot arm is programmed separately through the Allcode API, which is compatible with multiple programming languages. Curriculum is, as usual, available free of charge from the Matrix TSL Learning Centre on the website. Do not hesitate to get in touch with us for more information or pricing for this Industry 4.0 solution and much more from Matrix for the delivery of your course. Okay, hopefully that was very succinct for you and clear, and that's a video that's now available on our YouTube channel and can be used by yourselves to send out to customers, or if you want any further clarification on that, just let us know. I'll make sure that I send you a link to the video when we send you a follow-up to this webinar. So just let me go back into the presentation now. Okay, so yeah, the video's there. So let's kick off then with a bit of a product description. You may well have seen other companies in the education field who are developing this type of product and presenting it as a solution for education. What we've done is, along with a lot of our other equipment, is really scaled down the product to a desktop-based system. Now, what this means is that the system doesn't take up so much room in the lab. You'll get a good idea for the size of this system when we share a video with you of the demonstration shortly. The other point to make as well is that you will find the dimensions, of this product in the specification document, which is available now in the dealer portal. I'll make sure, though, that we attach, when we send a follow-up to this webinar, a copy of the specification for you as well. Other companies developing this type of smart factory product often have a really huge glory piece of equipment that fits together, and I have to confess, I often find that it's not a very well used product when I see others with this type of product in the field. And these come from all sorts of fantastic companies like Festo and Amatrol, for example. The idea with our system, though, is it's desktop. Now, what we are finding with the first sales that we've made in the UK, because we've been kind of pre-selling this to a couple of institutions already, is that most people are looking for more than one setup. So they're looking for maybe 2, 3, or 4 setups, which are in the lab, allowing students to work in small groups. And I'll explain shortly how we expect people to work with this system. But just to kind of summarize the system itself, the Smart Factory allows students to get experience of a number of processes and technologies, particularly focusing around manufacturing and modern day Industry 4.0 principles. Industry 4.0 is something that I'm sure we've all come across or heard of in our experience within education, particularly over the last few years. Industry 4.0 is the kind of move towards automated factories that we're seeing with robotics, smart sensor technology, and so on. And students within education now are being expected to learn about how a factory that has been put together in a smart manner, in a smart way, with robotics and all sorts of other equipment like this, how it might operate. And this system is designed on a small scale to give students that kind of experience. The Smart Factory that we've put together includes a conveyor system, sensing systems, pneumatic pick and place technology, DC motor drives, and stepper motor drives as well. And what you can see on the right side of the screen there as well is the optional control systems that are used to control the Smart Factory. And we'll come on to those a little more later. But just to give you an idea, users have the option for Siemens or Mayak control with the Smart Factory system. So we'll come on to that in a few slides' time. All important for any equipment that we develop is what are the learning objectives that the student will learn about and understand when they've when they've studied using this piece of equipment. And what we've listed off there is a range of learning objectives that the students will understand and know more about once they've used this Smart Factory system. So stepper motor drives, they'll learn about limit switches, rotational to linear movement with stepper motors, electro-pneumatic valves, specifically 3-2 and 5-2 valves, vacuum suction systems, positional control, DC motor control using PWM, rotational to linear movement with DC drives, inductive and capacitive sensors and light gates, which are on the conveyor system as explained in the video that we watched, positional control with DC motors using timing, rejection mechanisms that are again on the conveyor system, and then moving on to learning about robot arm workspace and planning, robot arm movement, and pendant and G-code programming using the robot arm as well. So there's a whole range of learning objectives that the students will pick up and learn about using this system. We've just put together this really simple kind of graphic of the smart factory, which explains in quite easy terms what you see on the system itself. So point one there at the back of the smart factory is the gantry system. We really do split the system into three core areas. There's the gantry system at the back there, which is point number one. And point number two is the plunger or the suction device, which is fitted to the gantry and takes the work pieces from the loading bays, which are set up just under point one, which you'll see when we run the demonstration. The second area is at point three, where we have the conveyor system. And this is fitted with the light gates, the sensors, and so on, which help to detect the type of material that is being used on the conveyor system, and then sort into the bins, which are at point five. The electro-pneumatic and pneumatic parts that are on the smart factory system are all powered and controlled using the electro-pneumatic components, which are situated mainly at point four, which you can see again on this graphic as well. If we just jump over point five there, because that's just the sorting bins, which I explained previously. Point six is the location point for the robot arm production cell. And now we also supply with this system what we call what's the thing on the base plate that we put on for the registration plate. Yeah, just sorry, I forgot the name of that. But the registration plate is located at point six and allows you to include the robot arm production cell. And then finally point seven, which are the sorting bins, which allow you to, once the counters have been taken from the conveyor system, placed on the color sensor, it then allows you to place into the sorting bins at point seven. So that's the smart factory, and that's product AU4956. What the user then has to do is they then have to decide upon a control system that they want to use to control the smart factory. And here the customer has two options. Option number one is that they opt for the MIAC add-on. Like I say, you have one of these two options. I'm guessing some circumstances people might want both, but in most, I guess that people will probably want to choose one or the other. So the first option is a MIAC option, which gives a straightforward educational PLC approach to controlling the system. So if the user opts for this methodology, they receive two cased MIACs, which look like you see on screen here. Now, the demonstration that we run in a few minutes' time will also use the MIACs as well. The MIACs are fitted with 4mm connectors, which are built in. Now, unlike our other MIAC-based products, we don't supply the MIACs with pre-programmed examples already loaded onto them. The curriculum addresses the need for students to actually program the PLC, whether it be the MIAC or the Siemens option themselves, in order to control the smart factory system. So please note that these are not pre-programmed. The idea is that the students will learn about programming these as they go through the course. Okay, so that's option one, is to control the system using MIAC. If this option is chosen by the user, then we advise that the user will require flow code in order to program the MIAC to control the smart factory system. In most circumstances, people will need just a one user license of flow code, which is very affordable, and we'll go through pricing in a few slides time. And what's more, the software of flow code, which can be used to control the MIAC, can also be used for control of the robot arm production cell, although it's not necessary, because the robot arm production cell uses all code technology, which of course allows control from any software system. If you have Flowcode, then you can use, for example, the G-code pendant programmer or other methodology through Flowcode in order to program the robot arm itself. And the G-code pendant programmer is particularly effective for the tasks and exercises associated with the Smart Factory. So if you're going for MIAC, then we would also advise that you go for Flowcode as well. The second option for controlling the Smart Factory system is a Siemens add-on. Okay. Now, whereas with the MIAC option, the customer will be supplied with two cased MIACs with the 4mm connectors because of the requirements for I/O, etc. With the Siemens add-on option, the customer is supplied instead with a Siemens S7 1200, which you can see on the visual here, which is placed on a PLC bracket with 4mm connected adapters. Only one of these is required because the Siemens has more I/O expansion and things in order to control the Smart Factory system. Now, the back plane, the PLC bracket that this is placed on, can then be connected to the side of the Smart Factory in order to give what I would consider to be a more compact, complete solution than with the MIAC. But the option is there. If the students are looking to learn about industrial PLCs and controllers like the Siemens, then this is the option that they want to go for. If an educational PLC is acceptable, then the MIAC system may be more applicable for the user. I anticipate that the Siemens option will probably be more popular. And in fact, with the meetings, quotes, discussions, and sales that we've had already for this product, that is proving to be the case. Now, if the customer opts for the Siemens solution for control, then they will require the software in order to program the Siemens PLC. And that is SIMATIC Step 7 software. Now here, really we have options in that we advise that academic institutions can source the software to program the PLC locally. We do that because we know that educational discounts can be acquired from Siemens resellers and things that mean you don't have to pay too much for the Siemens software for one of these PLCs. However, we also, as a Siemens education partner, which I'm sure you all know, we can assist with this process and we can acquire the software license if it's required. Just let us know as you're working on projects and suggestions for this particular product with your customers, and we can for sure help you out with this as well. Okay. Now, we've mentioned already that there is another additional optional product for this system as well, which is our robot arm production cell. This is a product that we launched, I think, last year, and most of you will already be familiar with this, and some of you may already have customers using this particular product. The robot arm production cell is a standalone product on its own with a whole set of specific learning objectives relating to the product, a whole curriculum that students can follow when learning using this product as well. However, we've also built this product now into the Smart Factory system. It's not an absolute necessity that they use the robot arm with the Smart Factory. However, we advise that it is used because it allows for the students to go through the full course with the Smart Factory and use the complete system together. So when you are proposing this product to your customers, I would probably say that you'd be best to make the suggestion that this is also purchased as well. But you do know, though, that if any restrictions with regards budget, for example, are there, then they can always have this as an optional piece that does not have to be included. And most of the curriculum can then be followed without the robot arm production cell. Okay. So just to summarize purchasing options for you then. First of all, the customer will need the Smart Factory, of course. That is the AU4956. That is a necessary item. And alongside that, they may also want our desktop compressor, which is the same desktop compressor that we use for our automatics range, which this product sits within. Then the customer needs to choose a control option. And we've been through that. It's either control option 1 with Siemens or control option 2 with MIAC. and then the related software needs to also be available to the customer as well. And then finally, the robot arm production cell, which we advise is also added to the system, but is of course optional. Okay, so let's get on to pricing then. I've highlighted a few products here, but this is the full range of pricing that you've got for this particular product. If we just go down this list, the top two products there is that we have are the compressors, okay, which are inexpensive and can also be sourced locally if that's preferable. Or sometimes we work with customers where they already have compressed air in the lab, which is not a problem as well. Next on the list, because of the numbering, are the control options. And you'll see 3 Siemens control options and 3 Mayak control options. The only difference is in the product codes here. So it's just whether the EU, US, or UK plugs and power sources are required for those particular products. Down the right side here, you've got the recommended sales price to the customer, and then you've got the dealer price to you guys as our reps and dealers. And you can see that pricing there. So there is a little bit of a difference. The Siemens option is a little more expensive than the Mayak option. So you're talking a couple of £100 more expensive that you can see on the right side. Then finally, towards the bottom of here, what we have is the Smart Factory system, which is £5,000 sales price recommended to the customer, and your price as dealers £4,000. And then the robot arm production cell, which you should already have the pricing for. It's not changed, but it's just there on this list as well, just in case. And then finally at the bottom, you've got the Flowcode software as well, which is a £299 sales price if the customer is opting for the Mayak control add-on. Just at the bottom there, I've just highlighted and said that in yellow, I've put what I expect. I'm not saying this is going to be correct, but what I expect to be a standard offering, what most people I think will go for, which is the compressor, the Smart Factory, the Siemens control add-on, and the robot arm production cell. And the pricing for that is just short of £7,500 plus the Siemens software, meaning your price is £5,897 plus the Siemens software. So what you've got here is quite an affordable Smart Factory system. We do expect that most customers will want more than one system over time. Initially, they may just opt for one system, but hopefully this gives you an affordable way to offer your customers a way to study about Industry 4.0, smart factories, robotics, and other type topics. Curriculum then. As normal, this is available already on our website. It's available in the Learning Center, which is at matrixtsl.com/learning. The Smart Factory is split into 4 sections. Section 1 is, this kind of explains how we'd expect a user to be using this system as well. So in some cases, we'll find that they have maybe 1 or 2 of these systems in their lab set up. And what people will do is they'll split the students into small groups of, say, 3 or 4. So one small group of students will be working on the conveyor system, and they'll be learning about understanding those sensors and reject mechanisms, understanding the conveyor system and how it works, and programming that whilst they go through. Another small group of students will be working on the gantry system. And the gantry system is where of course the stepper motor, the limit switches and the plunger are located, and they'll learn about how they program that particular system. And then another group of students will be learning about the robot arm, okay? And then at the end, they will bring this together to create what we call the Smart Factory. So they'll go through this and they'll complete the system. And this is the curriculum. It's available now on the website. I would advise you to go and have a look at it. As usual with our products, the curriculum is there in order for you to utilize it as a sales tool. It should give your customer a good idea about what their students are going to learn, the worksheets and the methodology that they're going to go through as they learn this course. And so I think it's a really powerful sales tool that you can utilize. And that's why we offer this for free. Okay. So that's there and it's ready. The curriculum's on our website. And of course, students can take this further. The program, we give an advisable setup for the Smart Factory, but there's no reason why they can't change that setup. There's no reason why they can't go on to have a second Smart Factory and perhaps even use the two in tandem as well. That's something else that we'd like to see students and customers doing too. So hopefully this is more than helpful. Now before we go on to a demonstration, which I think we'll be ready for in a couple of minutes, I just want to explain a little bit more about Industry 4. There are many other requirements with Industry 4.0 in order for students to learn about the particular topic in mind. Not just learning about smart factories, but we provide a whole load of equipment and a lot of curriculum that gives students an understanding of why and how smart factories and Industry 4.0 is changing the face of manufacturing globally. Students not only with Industry 4.0 learn about the latest technologies that make smart factories work, but also about communications protocols, things like RFID, Bluetooth technology and things, programming these types of systems, how PLCs work, robotics, sensors, and so on. And so with all of this in mind, we've now developed a brochure which is focused around all of the solutions that we have to meet requirements for Industry 4.0. Here in the United Kingdom, there is actually we have a qualification which is widely studied across the country by students aged 16 to 18. This is called a BTEC. BTECs in engineering now include a specific unit which is entitled Industry 4.0. Okay, and we have developed this particular brochure with that in mind. And it includes a whole range of our products, including the Smart Factory and the Robot Arm Production Cell, as we've already touched on today, but then also communications protocols using Arduino and Flowcode, and then two other products which are really useful for this type of study. We've presented these to you in the past, and as you'll already know, these products also have remote control capabilities as well, which means students don't have to be sat with a wired connection between the hardware system and their PC in order to control our electrical machines or process control systems. These can be controlled remotely, overseas, from a different town, from a different lab within the classroom, within the college or university, or school or whatever. So these products that we put together in this brochure hopefully give you a good insight into the solutions that we have for Industry 4.0. So we've got, I can send you the files for this particular brochure if you want them, and we've had a whole range of them printed. I think I'm just going to stop the sharing my screen now, and you'll find here a whole range of these brochures with the products in mind, okay, available from us. Okay, right, I think before we go on to a demonstration then, we've had a few questions that have come through as well. So let me just take a look at the chat and see if any of those questions need addressing. First question is regarding the video. So that a stamped list so that you can add your translations to the voiceover, and I'm sure that we have a version of that as well. So let me make a note of that and ensure that I supply that if it is available. Another question that came through is, do you always need the Flowcode software with the MIAC? It's the easiest way for students to program the MIAC because all of the software is built around the MIAC. It's very easy for them to use Flowcode, so it makes the life of yourselves and the customer much easier. And of course, you only need a one-user license, which means it's not overly expensive. But the answer to your question is not always, and there are other ways that you can program the MIAC which don't include Flowcode. But I would say for an educational institution, most of the time a one-user license of the software will be enough for them to do what they need to do. So we would advise it, yes. Do you have written exercises using Siemens PLCs? I think we have some of these available. I'll make a note and see if we've got these on our website. The web link that I provided in the presentation is where we will locate any of the resources that are available for the particular specific product. But like I said with the MIAC, the idea here is that the student learns how to program the PLC in order to control the smart factory. So we're not providing pre-written example programs for the Siemens PLC like we do with some of our other products. For example, within our automatics range, we have a Siemens PLC add-on for automatics, which includes pre-programmed programs which are on the Siemens PLC. That's not the idea here, because the idea here instead is that the students learn how to develop those programs as they go through. Okay. Does the compressor have an air storage tank? I don't think it I'll show you the compressor. Sorry.
Unless it's in there now.
No, I don't think it does. No, I'm just speaking to one of our engineers, Jack, there, and we don't think it does have a storage tank. So that should be fine. Final question then. Weights, ruggedness, expected time to complete the project. The course is a 20-hour course. Okay, so that's how long we would expect a student to go through this particular project. But of course, that can vary depending on students' I guess, level of study, age, and that type of thing. Weight is in the specification, I believe. So that I don't know off the top of my head, but when I send you the specifications, you'll be able to see that. Ruggedness, very rugged. I don't quite know how to you know, like any of our products, this is very rugged. What you will notice is that we've used a lot more metal pieces now. With our automatic system, we use Perspex plastic, okay, so that we can easily stamp onto them the circuit symbols. Whereas with this system, we've used bent metal. So I think that the metal, what specific metal is it that's used on the components for
1.2 mild steel,
which is 1.2 mil mild steel. That's black anodized, is it, as well?
Zinc plated, yeah.
Zinc plated. Okay. So ruggedness with this system is high. We don't expect this to be a system that needs to be replacement parts purchased or anything like that. Okay. Another good question that's come through is about students' pre-knowledge. I feel that the only pre-knowledge that they might require is some understanding and knowledge of programming PLCs. Okay. That's, for example, for the Siemens system. If they're already doing work with Siemens, then that will be a big help for the students. If they opt for the MIAC system, that's a lot easier. And I think students picking that up and going through our course and learning it would be a lot easier than understanding the ladder logic behind programming Siemens PLCs. So if they're going for that Siemens system, then I would suggest that they have some prior knowledge of programming Siemens PLCs before they jump into doing this. Okay, I'm going to pause the questions there. You can always ask more by all means, but I'm just going to switch over to my colleague, Jack. Jack, do you want to just come and say hi? Jack's behind us here. Yeah. You've probably not met Jack before, but he's been with us for a year now, and he's one of our engineers. He's our senior mechanical engineer, and he was in charge of the development of this particular project. So he's going to just set us up with a quick demonstration of this, and we'll talk you through it. Okay. Yeah. I'm just going to set that up, Jack. So before we do that, as I said earlier, I am going to ensure that we send you pricing. We send you the specification, the video, the presentation, and a recording of this webinar, along with any other further information that you might need in a few hours' time once we run the afternoon session. Okay, so I'm just going to switch the video over, and hopefully you can see the system here. So, Jack, do you want to just first of all point out the compressor, which is at the back there.
Yeah.
So that's the compressor. Yeah, that's it. The compressor system, which is just at the back of the smart factory over there. So that's a small desktop compressor that we have. So I don't think there'll be any issues with vessels or anything with regards to an air storage tank. Before we run through the demonstration, Jack, do you want to, if I just switch the mic, do you want to just give us a bit of a run through about what we see there? I mean, it's fairly clear to people. But...
Yeah. So as most of the videos show, we've laid it out in a way that we feel is the most optimized. But again, this is a modular system that the kids can pick up and place. They can put things in there their own way. They can be super creative with this. If they decide they want all of this section of components over here, for example, well, they can. This just happens to be optimized that we think it works in a sensible manner. So we'll start over here. It starts with the manifold. We've got a couple of the pneumatic controls, like a 3-2 valves, a 5-2 valves, the vacuum chamber, which all control the control of the pneumatic head, the plunger, and then you've got the motor control here for the movement on the gantry. This unit here, which is sort of a H sort of frame, is self-contained. There's no assembly or anything like that. I could lift it off if I take off this 4 little bolts that are thumb screws effectively, so it's nice and easy to plug and play, and then all the sockets around the back so you can put your 4mm connectors in. I have the control of this mic controlling the gantry. Then we have the conveyor belt over here. The counters will be dropped at this end and they'll be moving down. You'll go past the sensing section and go to the 2 rejection methods over here. And again, I've got the mic control that's on that side, just controlling everything that's happening here. The DC motor is just here that moves the conveyor belt, and you'll see counters dropping off to the side or at the end over here. We provide 3 counters, or 3 types of counters, but in multiple numbers. You might be able to put these up on the camera, that we've got a aluminium 4mm counter and a steel one. You can see the colors are different and the weight's relatively obvious. So we provide those for. Now in the rack that we've got here, if I just sort of move the head of the robot arm, you'll see it. We've got 3 bins. Again, they can put the components in there as they want. I tend to just put them in the materials just because that's the easiest way of controlling it at the moment. So we'll have the steel, the aluminium, and then we've got some black plastic counters, exact same size, that the plunger will move through each of those spaces and pick them up. So I'll just show you that in motion for now. So we'll start that. It's going to go home to start with. Then it will start its first motion, and this one's going to hop array for now. So if I turned on the compressor, that would actually start. So
you want to start again?
Yeah, I will. So it'll go home, and it'll go down this time because the compressor is actually on. So it'll pick up the counter. It's relatively forgivable. The bellow on there gives it a nice sort of undulation left and right that it can move. It will go over, and you can see it's just dropped it on the conveyor belt to the side over there. Now, if I start this program, you'll see that the conveyor will move along and push the conveyor to the side. So it will go to the second bin now. It will take the aluminium. It will go over. It will drop. It will do the conveying, and it will eject one of those out to the side as well. We've got it set up that I could change the hoppers to add some randomness in it. Again, creativity of the students. They can choose how they want to do this. They could control the stepper motor in different ways. They could go to different hoppers. Here, the plastic counter will go through. It will go through the sensing motion, and we've got it stopping at the end of the conveyor. That allows then the robot arm to come in. But in this instance, I'm just going to say carry on, and it will drop on to the end. So if you didn't have the robot arm, that's the kind of action that we would expect. But in this case, we have the robot arm, so that's why we have that stopping function, and that means I've got somewhere that I can go and pick it up from, basically. Yeah. So I'm going to go back to off the C and go to the plastic ones. Now that stops, I can then start the robot arm program. Just going to pause that one. So we've got the robot arm coming in, picking left and right. I've gone through, found the XYZ positionings of where I want it to go. It's homing at the moment. It'll do its first movement. It'll come in, pick up the plastic counter. Now on this one, I'm picking up a black counter because we had them in the system. But you might be able to see here that I've got green and red counters. Now, if I just quickly place that green in before it gets there, it will choose the green or the red bin to put the right counter in. So let's pick the right bin here and off it drops. So that's how we've added the robot arm in. Now, again, there's flexibility of how they want to play this. If they want the robot arm to go to a second smart factory that's to the side here, well, then they could get the robot arm to reach over and drop it on the next conveyor belt, and then it could come down and start another sensing system. Just to give you a bit more explanation about what sensors are doing in our operation, but again, the exercise is taking them through from starting with one sensor, building it up to the 4 sensors. We've got light gate, inductive, capacitive. Light gate in that sort of order. If I spin it, you can see it. It goes open, so it starts the sensing motion. It does a binary logic across the two because it's checking the material. So a 0, 0 output will give you one of these bins, a 1, 0 will give you another, and a 1, 1 will give you the other. And then when the second light gate, goes, that gives you a timing element to give you the stopping function, and also closes that, so then these open up to start the paddle rejection. So that's it, yeah.
Okay. Okay, Jack, thank you very much. I think that was a fairly successful demonstration. Everything seemed to go to plan, I think, so that's really good. Yeah, thanks for giving us that run through. Okay, at this stage, I know maybe one more question's come through about noise of the system. I would say in the system that we're using here, by a long way, the compressor is the noisiest part of the system. And this is the same compressor that we have been supplying with our automatics range for many years. And so I don't anticipate that noise will be any sort of issue. The conveyor does make some noise, but that's quite minimal. The robot arm makes no noise, and I don't think that there is much noise comes from the gantry system neither. So the conveyor is probably, other than the compressor, the next noisiest part of this system. So noise level shouldn't be any specific issue. Okay. Okay, does at this stage anyone have any more questions? Because I think that probably concludes what we were going to talk about today and give you an introduction to. This is obviously a new product, but it's now available. We've supplied the first systems into education here in the UK, and we're ready to supply more when you guys start talking to your customers over the coming weeks. Of course, as usual, myself and Alistair, we're always here to answer any questions that you might have as you go out to ask to see your customers. But yeah, I'm more than happy to take any more questions that you might have now. So please feel free to unmute yourself if you want to chat, or to pop your questions into the chat box if you'd rather do it that way.
No further questions on my part. So thank you, Liam. And
Thanks,
Alistair, of course.
Nice to see you, and thank you very much.
I think it's a great product. So hopefully we can sell a lot of them.
Hopefully, yeah. Anybody else have any more questions? I think there has obviously been a number of questions, which is great because it means that hopefully we've addressed most of what we need to.
I've got a question.
Hello.
We order from Holland the smart factory, for instance. Do we have to insert the note, please supply with European plug, or do you do it automatically?
You mean so that we supply an EU power supply?
Yes.
Yes. So with the on the price list, you'll find EU versions of the products. Okay. It's only the control products that you need to worry about, because the smart factory itself doesn't have any plug that goes with it. It's the control products. So the PLC product, either the Siemens or the Mayak, where you need to consider whether you want the EU version. And if you just specify that on the order, we need the EU version of the plugs, then we'll make sure we supply you with those for everything. So just make sure you note it on the order when you send it to us. Okay?
Okay, thank you.
Okay, no problem. Anybody else? Okay. Great. I think that's good then. Hopefully we've addressed everything that people wanted to find out. And like I say, more than happy to help you as time goes on with you know, selling this product and suggesting it to your customers. Any customer questions that come through, send them to myself or Alistair, and we will support you. We'll ensure that we send you a follow-up, including recording, the presentation, pricing, etc. Today or tomorrow. Okay. Thank you and have a nice day. Goodbye.
Thank you.
Bye bye.
Bye.
See you next time.